Welcome back. Just to recall when we left off, we were working with a mean of 75 for 75,000 for annual household income and a standard deviation of 19. Up until this point, we were calculating probabilities with known x values using the norm.dist function. For these next few problems, we're going to now be given a probability under the normal distribution and calculate the x values for that. So in the previous one, we noticed that the difference between, or the probability between 60 and 100 would be about almost 70%. Let's work this a different way. Let's find the x values for the middle 50%. So the first thing we need to do is find the x value for the lower 25%. Then we'll find the x value for the lower 75%. Now we know what the probability is. That is, that left tail is already to be defined as 0.25. So in this case, we're going to go to Formula, Insert Function. Kind of give you a hint. It's norm.inv, but let's look at it the long way. Let's go down to Statistical. Drop down to the ends. Here's the norm.inv. Again, on the older versions, it may not have the .inv. The probability is going to be 0.25. The mean still stays at 75, and the standard deviation is 19. So we see that that's our value here. I'm going to make 3 decimal places because you could read that as 62,185. I'll pop that formula into column C. And there's our lower value for the range that will contain the middle 75%. The middle 50%. We'll repeat that process. Formula, insert function. Again, we can go back to most recently used. There it is right on top. The probability in this example will be 75% or 0.75. Notice our mean and standard deviation are still in B1 and B2. And, we could possibly use that a little bit more elegantly, but part of the goal for this video is to give you the practice to do this several times so you get comfortable with it and familiar with it. Again, we'll check that down to 3 decimals. And there is our lower and upper limits for the middle 50%. That also defines our interquartile range, where we could simply take the upper value minus the lower value. So our interquartile range is about $25,000 wide. Did that wrong. Meant to do that to B33. And there we go. Let's try another example with a middle. And this example has a purpose that we'll see later on. We're going to find the middle 95%. So in that case, we want to find the x value for the lower 2.5%. Again, don't forget, if it's a middle 95%, that means that there is 5% for both tails. So we have to divide that up into a lower 2.5% and an upper 97.5%. And then we can apply our norm distribution function again. Probability here is 0.025. You can even put in 0.25%. We'll try that with the upper one. B1 and B2, hope you're familiar with that by now. There's our lower range. So only 2.5% of the families make less than 37,761. Repeat that process. Again, hopefully you're getting comfortable with this. Let's try 75% this time. Nope, 97.5%. Just to show you can put it in. Notice it changes it to the decimal. It recognizes the percentage. That's something that may be helpful for working with various things in your own business world. All right, there's the upper limit. Get that to 3 decimals. So we know that 95% of the families make between 37,761 and 112,239. That's a pretty wide limit. And let's finish up this series calculating the z-score for the 97.5 percentile, just to kind of wrap everything up. Let me get that 97.5 in there. So the z-score, calculated as we've done, take the 112 minus the 75, divide it by the 19. Whoops, I didn't do that very well. Equals, parentheses, the 112 minus the 75. Let's close those parentheses and divide by 19. And we see that that z-score is 1.96, very, very close to 2. And another good example of how the empirical rule works. Except that it works better when I do it right. That is better. And so there you have it. Just to wrap up, all we did is calculate some probabilities for a symmetrically middle 50% and a symmetrically middle 95%. Again, using the same principles that we did for calculating probabilities for specific X or income values. And hopefully that will give you a good sense as to how this works. And of course, finishing up with a z-score, linking back to the all-important empirical rule.